Hello everyone, welcome to my YouTube channel. So today I am going to do a small introduction about calculus. Calculus is a subject related with mathematics and it is being used in various subjects like in physics, chemistry and economics and etc. And the two main characters that have done a main role in the field of this subject is none other than Sir Isaac Newton and our well-known mathematician Gottfried Wilhelm, who's also known as the inventor of the modern day calculator. And he is the person who found most of the calculus notation symbols that we use today, and the integral sign and the derivative sign are some examples. And Sir Isaac Newton is well known to be the father of this subject, but some believe that Gottfried Wilhelm is the true father of calculus. And there even had a debate between these two mathematicians on who should gain credit for the discovery of this subject. And that's a brief history of calculus. And now we are going to talk about the basic concept of this subject. So the basic idea which caused the discovery of this subject comes from Greek, and ancient Greeks knew the way of calculating the area of any triangle. And using the way of calculating the area of triangles, they they knew the way of calculating they made the method of calculating the area of polygons. To demonstrate their method, I'm gonna use a pentagon. So this is the method. So first we are going to divide this polygon into a several triangles as I'm doing here, and then we are going to calculate the areas of these three triangles, and then we are going to add those values up, and that's all with everything that we need to solve for the area of this shape. And they also found that the minimum number of triangles that we can obtain by dividing a polygon by straight lines is the number of edges minus 2. Now when we take this polygon, this is a pentagon, so it has 5 straight edges, and 5 minus 2 is 3, and for sure there are 3 triangles. But a small problem occurred when they tried to solve for the area of a circle. Unlike polygons, a circle cannot be divided into triangles, and they had to come up with a general formula, a new general formula for the area of a circle. And 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 the, and the idea that they used to derive a general formula for the area of a circle became the key idea which caused the discovery of calculus. And here's the method that they used to solve for the to derive the area of a circle. So let's suppose that this is the circle that we want to solve for the area, and we are dividing this circle into a several number of strips as shown in this diagram, and then we are gonna arrange all of those strips in this kind of a manner. So as you guys can see here, the sum of the areas of these of these strips is a value closer to the area of this triangle. So the height of this triangle is a value closer to the height or else the length of the longest strip of the circle. So the length of the longest strip of the circle is equal to the circumference of the circle, and we can estimate they can estimate that the height of this triangle to be equal to 2 pi r, and the length of the base of this triangle is equal to the radius, as this is, and now the length of this line is the same thing as the distance from the center of the circle to its edge, and a line drawn from the center of a circle to its edge is a radius, and that's the reason why the length of the base of this triangle is going to be equal to the radius of this circle. And now we can solve for the area of this triangle and estimate the area of this circle. So we know that the formula for the area of a triangle is 1/2 base times height. We know that, and in our case the value of b is equal to 2 pi r. Sorry, the value of h is 2 pi r, the value of b is just r, and we need to multiply this quantity by 1/2, and 2 and 1/2 will get cancelled. They will cancel out each other, and r's will combine to become r squared, and now we are left with our good old formula for the area of a circle, pi r squared. And the concept that they used to derive this formula is the key concept which caused the discovery of the subject. And scientists and mathematicians started to use this method to estimate the area under curves. So to make our estimation even more precise, we are going to use thinner strips. Thinner the strips that we are dividing the circle into, the more precise our answer is gonna be. And if we divide our circle into infinitely thin strips and arrange all of those strips in this kind of a manner, all of those strips will perfectly fit to under this triangle, and the area and we can simply solve for the area of it, and the area of this triangle is exactly going to be equal to the area of our circle. And it's clear that if we use if we divide our circle into infinitely thin strips, our answer is going to be 100% correct. And the same concept is applicable when solving for the area under curves. Unlike when solving for the area under graphs only with straight lines, we can't solve for the area under curves using the formula 1/2 base times height. We can't divide regions into triangles and solve for the area, and because it's a curve. So we can apply the same concept when solving for the area under a curve. So in our first diagram, our answer is gonna be really imprecise, as the thickness of the strips are really big, and in the second diagram, the strips are much thinner, and it's much better than the first diagram. And the third one is the answer we get from the third diagram is a value much better than the answer we get using red color strips, and the fourth in the fourth diagram our answer is going to be really precise. And if we used even thinner strips, our answer is gonna get even more precise. So if we used infinitely thin strips, our answer is gonna exactly match our answer is going to be exactly equal to the area under this curve. And if we want to study this subject even more deeply, first you need to study things like integrals, derivatives, and most importantly about xy planes. You need to know how to graph equations, linear equations, quadratic equations. First you got to learn those things before studying this subject. And that's all for today. Hope you guys enjoyed this video. See you guys in a future video.